Here we have a scatter plot, and the dots seem to fit into a pretty nice narrow band here, and that band seems to be pretty linear. It seems to make pretty much of a straight line. Now when we have two variables that we think are correlated, the first thing that we would do is construct one of these scatter plots. And these scatter plots, again, they consist of x and y ordered pairs. So here we have a dot, for instance, that seems to have an x value of about 20 and a y value of about 16. So each one of these dots then is an xy ordered pair, and they represent two variables that appear to be correlated. And we might call these two variables x and y. Recall that x is sometimes called the independent variable, which you would probably remember from algebra, and y would be called the dependent variable. And in statistics, x is frequently called the explanatory variable, and y is the dependent or response variable. Now when we have this nice tight narrow band here like we have in this example, then there may be a nice linear equation like this red line that's graphed here that describes pretty well what the relationship is between these two variables x and y. In another video we will develop the techniques for determining what the equation of this line is. But for right now, let's just notice that there is a nice line that fits inside these ordered pairs on this scatter plot. Now, the dots on the line would be called the predicted values. So the y coordinate of this dot here on the line would be a predicted value. The actual values here, the actual y values that are observed in the ordered pairs, then of course would be called observed values. And we can see that for this one x value, we actually have 3 observed values. Now the distance between the predicted and observed values would be called the residual. And this residual, again, is the distance between the observed value and the predicted value. Now, if the observed value is above the line, then that residual would be positive. If the residual is, or if the observed value is below this line, then the corresponding residual would be negative, because you'd be taking a larger number and subtracting a smaller number, or taking a smaller number and subtracting a larger number. So here we have a positive residual, here we have a negative residual, positive residual, positive, negative, positive and 2 negatives, positive, negative, and on up. Now, these residuals then could be plotted against the x values. And basically what you're doing is you're taking this line, this what we call a fitted line, and rotating it down till it's horizontal. And then we can see a little bit better what these actual residual values are, rather than seeing them related to this slanted line like this. So here we have these, again, corresponding ordered pairs, only this time the y value is that residual. So you see, again, we have 2 positive residuals here and then a negative residual here in these dots. And then with these 2 here, we have a positive one and a negative one. One above y equals 0 and one below y equals 0. Okay, now what is the value of this residual plot? Well, if we notice that there seems to be this kind of equal distribution above and below this this y equals 0 line, and any fitted line or curve that might go through these dots could only be horizontal. I mean, we certainly don't see any other relationship going on here. It's not, there's no like curved relationship of any kind, or, you know, any kind of an exponential or logarithmic looking relationship. The only thing that we could draw through that big scattered mess would just be a horizontal line. If that's the case, then this scatter plot might represent two variables, x and y, that could be explained or related with a linear equation. And that linear equation would be in the form y equals mx plus b if we were in algebra. But in statistics, the way we write that is y hat, which means predicted y value, equals a plus bx. And we'll talk about all of this a lot more later. The point of what we're talking about now is to note this tight band, this tight linear band that we have that sort of encases this scatter plot. And then note that a line, a nice straight line, goes through them pretty well. And then the scatter plot of the residuals against the x values gives us nothing better than just maybe a horizontal line.